Welcome to Disrupting Japan, straight talk from Japan's most successful entrepreneurs. I'm Tim Romero, and thanks for joining me. There are a surprising number of new aerospace startups in Japan, and today you'll be meeting the founder of one of the most innovative ones. Nobu Okada founded Astroscale to solve the problem with space debris. You see, every year we're putting more and more satellites into orbit, and it's gotten kind of crowded up there. There are zombie satellites that we've lost control over, and there are satellites that have collided, resulting in thousands of small pieces of debris zipping around in random orbits at thousands of miles per hour, just waiting to crash into other satellites and begin a chain reaction. Well, Nobu and the team want to do something about that. They have a plan to start deorbiting this debris. And the technology side is fascinating. I mean, you might think that you have no real desire to know how to deorbit a satellite, but trust me, you want to know how to deorbit a satellite. It's really that cool. Of course, Nobu and I cover much more than the technology. A big part of the story is how Astroscale has begun to build international recognition and consensus, and how they've actually constructed a business model around debris removal. And we also talk about the forces driving the sudden growth of aerospace startups and talk a bit about dancing satellites. But you know, Nobu tells that story much better than I can. So let's get right to the interview. We're sitting here with Nobu Okada, the CEO and founder of Astroscale, who's cleaning up space. So thanks for sitting down with us.
It's a great pleasure to meet with you, and thank you for this great opportunity to be on your podcast.
Well, I'm delighted to have you. And I've got to say, Astroscale is not like your typical startup. You have a really unique mission. So can you kind of explain what your vision is and what you're trying to do?
Our mission is to secure long-term spaceflight safety by removing the space debris. So space debris is junk in space. They are made of rocket upper bodies and old satellites and fragments caused by the explosion and collision among them.
How much space debris is up there?
There are a variety of size of debris. If we count the objects, which is larger than 10 centimeters, there are more than 23,000. And the bigger one is like 8 meters, 10 meters, like a bus, double-decker bus.
Okay. So it's quite a range of sizes.
Yeah, the small one is like a 1 millimeter, less than 1 millimeter. So yeah, it's a wide range.
Right. And even like a 1 millimeter size object can do a tremendous amount of damage to a satellite or a spacecraft.
Yeah, right. They are flying with 7 to 8 kilometers per second, which means 40 times faster than the bullet. And so it's quite fast, and they have a huge power to blow up other objects in space.
Part of the problem, as I understand it, is that space debris kind of multiplies on its own, that like these larger objects will collide with each other and make more and more smaller objects. And the worst case scenario is the Kessler condition, where there's so many of these tiny objects, it becomes extremely difficult to launch a satellite or to launch a rocket.
Yeah, that's right. The density of the space debris has reached to a certain threshold where what we said is Kessler syndrome, which is a kind of the situation where chain reaction of the collision happens. We already reached that threshold. So it is kind of a consensus among the space industry that we should remove large objects now before they get smaller.
Okay, so we're really at that tipping point where if we don't do something now, we won't be able to do anything in the future.
That's right. There are so many discussions, papers, or research works when we will not be able to use this space anymore. And well, we don't know. It all depends on when catastrophic collision happens. We don't know. It might happen 100 years later or today. We don't know. So we should develop the technologies, business model, and regulations ready for removing the debris.
Okay. I want to get into the details of exactly how Astroscale is doing this and the challenges you're facing. But before that, I want to talk a little about you. You founded Astroscale back in 2013, and at that time you had no background in aerospace at all. So what attracted you to this problem, and what was the trigger that made you decide, I'm going to start a startup to remove space debris?
When I was 15, I went to NASA in America. There was a space camp program where we can have a kind of a junior training to become an astronaut. It's kind of a fun entertainment.
I remember space camp well. I wanted to go so bad when I was a kid. I never had the chance.
But it was fun. It was fun. And I met with the real astronauts and NASA engineers. And they ignited a passion within my mindset. But what I found, there's no astronaut's job. Physician can be an astronaut, or pilot can be an astronaut, but there's no astronaut's job.
So they take someone who's got a necessary specialty,
right,
and then they train that person to be an astronaut.
Right, that's right. So what I learned is I have to have some major in specialty in somewhere else, and then change my kind of a career path toward astronaut. And then I went to the government, the Japanese Ministry of Finance, and I was working for a consulting firm. I ran 2 IT companies.
Well, this seems like an unusual path to become an astronaut. I mean, they don't send up too many management consultants or financial types.
I was almost forgetting about astronaut. When I turned to 40, when I was 39, I became a midlife crisis, kind of a typical situation where people feel about what should we do. I have several people who I respect, but they did something good during 40s, but when I was 39, I had no idea what should I do during my 40s. All of a sudden, I remembered the days in NASA. Oh, space. Space is something I really wanted to do. At that time, I had been running an IT company for 10 years. I had been dedicated into software industry. I felt like I really want to work on hardware too. And then, keyword, space. And then I attended a couple of the space conferences to see what are the hot topics. And then I found the space debris was a growing threat. And then there was a space debris conference, dedicated for space debris in Germany in 2013 April. And what I saw were research concept simulations. I didn't see any actions.
Yeah, well, I think that aerospace in general and space in particular is very much on the old, decades-long government research financing cycle. I can understand your attraction to the problem and thinking, okay, we can apply modern business methods and modern startup initiatives to this seemingly intractable problem. But once you had that motivation, what's your next step? I mean, did you start talking to researchers? How did you get your technical team together so you could credibly address this problem?
I had a wide range of the options. I can join the space agency, or I can be a kind of independent consultant to advocate this issue, or I can go to the university or graduate school and to study again, or I stand up and develop solutions. I had no idea about engineering. If you Google satellite development, how to develop satellites, there's nothing actually. There are so many papers coming up, but it's really hard to understand.
Yeah. It's an incredibly specialized field.
Right. So what I did is I got CD-ROMs from the space conferences, printed out, and I read all the papers.
Just hundreds of papers.
700.
Wow.
In total.
Okay.
I had intensive readings for 300. First reading, I got stuck in each jargons, but I tried to read through again and again. I got all the jargons in the end, and then I came up with a hypothesis how to solve this issue. Not only technology, but also kind of business model and regulations, and then all the paper have an email account for each authors. So I contacted them. I read your paper. I really want to discuss more about your paper, and I had a world tour. In my first year, I had a 4-round.
4 times around the world, just meeting with scientists and researchers.
Yeah, that's right. At the beginning, it was really miserable because I didn't know the basics, but they are so kind to tell me the basics. For one example is one professor said, "Okay, I can give you 30 minutes to discuss," and in the end, we talked half a day.
Well, I mean, I guess that makes sense. I mean, you are trying to make a genuine effort to solve a problem that they're very concerned about.
Yeah, that's right. But I was just a stranger, so I really have to say thank you to them. But I was very motivated because at the beginning, people told me there's no market and there's no proven technology. The regulation is so complex. And they said, no. But when I heard there's no market, is this a good news or bad news? I felt like this is good news. When I was running IT company, I always had hundreds of competitors. When I heard there's no market, which means there's no competitor, that's a kind of blue sky for me.
Well, it's like you say, it is good and it's bad, right? Yeah. So it's good in that if you get it right, you have the whole market to yourself.
Right.
It's bad because it's a lot harder to get it right the first time.
That's right. If there's no competitor, we can dedicate ourselves to do the right things.
So you had tremendous amount of support from your worldwide tour for kind of self-education about the problem. And is that network how you recruited your initial team?
Yeah, that's right. For example, to develop satellites, there were 2 options. One is we do design, outsource manufacturing. Option 2 is we set up our own facility and internalize technology and develop by ourselves. Which is better? One of the great space company in America told me, "Hey, Nobu, you should internalize technology. Otherwise, you cannot make innovation." So I decided to have our own facility, but we need the capital for that.
I was going to say that path takes a lot more capital.
More capital, but that is a way to make innovation.
All right. Okay, let's get into it. How exactly does Astroscale work? I mean, how do you deorbit a satellite that doesn't want to be deorbited? So I assume that in most situations, there's no control of the satellite. It's kind of strange physics involved in trying to grab it. How does it work?
Yeah, so like this. When you go up to the space, there are so many lights. Moon, Earth, Sun, stars, garbages. Mm-hmm. And then you have to identify which is our target, which is our target debris. And then we have to approach to the debris, which is flying with 7-8 kilometers per second in different direction. So we have to make sure our relative speed would become 0. And then once you successfully approach the debris is tumbling, rotating actually. So how you're going to capture it? There are so many ideas about this, but what we will do is we will synchronize the motion. Our chaser satellite and capture satellite will dance with the target.
So if it's tumbling, your chaser satellite will sort of tumble with it?
With it, to make relative motion to 0.
That sounds like an incredibly difficult thing to do.
It's kind of something we have to spend a lot of time to develop technologies and then capture them.
So when you capture, is it like a claw? Is it an adhesive? Is it a net? How do you grab it?
The capture mechanism depend on the target characteristics. But what we are developing right now is magnet-based capture mechanism.
Magnetic.
Okay. And then once captured, you have to stabilize the motion and then bring them down to the atmosphere and burn. But before bringing them to the atmosphere, we have to identify the center of the gravity of the combined bodies. If we do not, if you give the power or thruster, you just tumble there.
Right, a tiny mistake, and instead of sending it back to Earth, you just make it spin faster.
Yeah, spin faster, that's it. So that's the whole sequence. Identify, approach, dance, capture, stabilize, identify the center of gravity, and deorbit.
So is the Chaser satellite is a single-use satellite?
Our Chaser satellite will burn together with the target. We had a lot of trade-offs. Demand is the cheapest solution. The one way is 101, capture one debris. The other one is like kind of develop this star of the Star Wars and then capture whole debris. But which is cheaper? And we found 101 is the best way.
So a single mission would deorbit a single satellite?
Yeah, and mass production is the cheapest way.
Interesting. So what is the launch schedule? What's your development schedule like?
So we're going to have a world first debris removal demonstration toward the end of next year. The day before yesterday, we had a ground station opening ceremony. So we are doing these kind of jobs day by day.
So what is that demonstration mission going to look like? What's going to happen?
So we're going to bring the target debris together rather than using the real debris. And we will test different situations. So, they capture the debris, stable debris at the beginning, and then detach, and then make the debris start tumbling, and then capture the tumbling debris by synchronizing the motion, and then detach again, and we say goodbye to the target far, far away, and then we lose it, and then we start finding it, and then approach, capture again, and then finally we bring the target down and burn.
Okay, so it's sort of a catch and release.
Catch and release. It's
program for different scenarios.
We play tag in space. It's going to be fun, big fun.
I'm looking forward to kind of watching it from afar. It's really interesting. Now, it is interesting, but how do you develop a business model around this? Because we've got a bit of sort of the tragedy of the commons here, where everyone agrees that this is a problem that somebody should solve. Nobody really wants to pay for it. So how do you build the business model around that? Who pays for this cleanup?
It has been a kind of fun process for us to think about the business model because we know this will be a big issue. As of today, people don't want to pay money at all. So there might be a kind of cross point where people want to pay money rather than doing nothing. And then,
who would want to pay money? Is it governments? Is it private industry who's lost control of their own satellites they want to deorbit?
Talking about debris which comes in future, the most of the debris comes from constellations. Going forward, companies will launch tens, hundreds, or thousands of satellites together rather than launching one single satellite. The satellite industry so far is something like this. Launch one satellite, take a picture of Tokyo twice a day. That's kind of a typical satellite mission. But going forward, companies will launch many satellites as a flock and then make sure we can see the satellites anywhere, anytime. Okay. To have a coverage all over the world. There are more than 100 programs of constellation right now. But unfortunately, some percentage of the satellites go defunct in space due to various reasons: radiation, malfunction in solar power, or whatever.
Yeah.
And then statistically, these will happen. Once their satellite go defunct, they have to replenish with a new satellite to keep the coverage.
Oh, I see. So they need to put up a new satellite in that same spot
Right.
where the old satellite is, but they can't do that until they pull the old satellite out of orbit.
That's our job. That's our job. So we are talking with constellation players very actively because they need us. So it's something like a AAA in America. So on the highway, if there's a broken car, we have to get rid of it. The orbit is kind of a highway in space, and there are many satellites that, flying around the orbit. If there's a broken satellite, we have to do the same kind of job,
Okay.
like AAA. But not only the constellations, we already have existing debris above us right now. There are environmentally critical objects, like 5 meters, 10 meters. Mass-wise, it's 1 ton, 3 ton, 8 ton. And those debris were littered by the governments because so far the space development has been done by governments. And we've been actively talking with governments in the world. And until 1 year ago, they were just listening mode. But quite recently, they changed their mindset. Now they understand how critical it is.
Well, and I think the fact that you're presenting a practical solution means that governments now have to make a decision. They can't just say, well, we're studying it, it's important. The existence of Astroscale is probably driving that.
I hope so. The other driver is the cost. So there were various type of the papers, how much it costs to remove one large object. And the paper said some are 200 million US dollars, some are 500 million US dollars. And then if we multiple with the number of critical objects, it's gigantic money. That's why government could not move forward. But we are thinking about a radically competitive price.
Okay.
And then governments can move forward.
But what about the small debris you were talking about? So sending a mission up to grab a large satellite and bring it down, I can understand the business model either for private constellations or governments acting responsibly. But what's the plan for all the tiny objects out there?
That's a great question. Thank you for asking us that question. So there are so many tiny space debris. We cannot remove them. There are so many, too small. So the only way is to protect our space assets against the tiny debris collisions. So to do that, we have to know the density of the small debris so that we can reflect that number toward our designing of the satellites. To do that, we have to monitor the small debris in space because we cannot see them from the ground. So what we did is last year we launched a satellite called IDEA OSG-1, which has a large sensor of the tiny debris. Unfortunately, due to the launch failure, we lost our satellite.
Oh, sorry to hear that.
It was sad news. We really wanted to operate the satellite and get the data, but the process toward the launch was also tough. Design a unique satellite and with a new team, ship out to the abroad and do the site operation and go through all the regulations. But we successfully done these processes. So although it was a sad event in the end, but we learned a lot.
Are you going to be rebuilding and relaunching?
We thought about a revenge strategy. We are thinking about it, but as of today, we see lots of growing demand for the debris removal. So we are now focusing on the debris removal right now. But we are always thinking about the tiny debris too.
So it sounds like the strategy is to focus on the large debris because you know how to bring that down. and hope that either Astroscale or some other clever company comes up with a way of dealing with the small debris in the future?
We always want to have more players because we cannot do this by ourselves. There's so many things to do. So if we can do everything, that'd be great. But if there's more players, that'd be also great.
Okay. What would you say is the biggest technological challenge that you have left to solve before your vision of Astroscale becomes a reality?
When we started this company, media always asked the question about what are the risks, and then I always had the same answer. There are technological risk, market risk, business risk, and blah, blah, blah. But today I feel differently. Technology, we have good team right now. Market exists right now. Business-wise, if we successfully deliver our solutions, services, we can make profit in the end. The risk is more in our organization right now. To meet the demand, we have to increase our capability, continue hiring the right people, and make a great teamwork. Actually, our culture is really good. I mean, people gather for purpose. It's quite simple mission, right? It's a clear mission, so that's great. But we have to continue.
Yeah, it sounds like you feel like you're on the right track, and now it's just a matter of executing.
Oh, yeah, right. Execution. Yeah, execution is a...
Let me ask you a couple questions about Japan in general. So there's a lot of interesting aerospace companies coming out of Japan now. And 10 years ago, it was basically zero. There were no aerospace startups in Japan. What's changed?
I see this as a worldwide trend. Now, I think we have 2,000 space startups in the world. When I started this company 5 years ago, there were only 3 startups. 10 years ago, 0. And now, as of today, more than 20 right now.
Wow.
So if we reach the 50, I think there will be an ecosystem in supply chain in Japan. This looks like IT industry in 1988 or 89.
But was there a trigger? Because aerospace in like 40s, 50s, 60s was just this tremendous time of change and innovation globally. And then there wasn't a whole lot of innovation for about 30 years. There were improvements, but there weren't any of these huge changes. And then all of a sudden, there's all this innovation again. And it is global. It's not just Japan.
But space industry has been following aviation industry by 50 to 60 years. Let me explain. So Wright brothers had a first flight in 1902, I think. And then due to the World War I and World War II, that technology advanced. And when the World War ended in 1945, several countries had flight technologies. And after that, the governments and the industry worked together to develop kind of a new airplanes.
Oh, to kind of commercialize that technology that was developed for the war.
Right. And from 1953, people started having a kind of commercial flight. And then, as of today, around 2 billion people flying around the world. Looking at the space industry, in 1957, Russia launched its first satellite. And then, thanks to the moon race and the Cold War, the technology advanced. And when Cold War ended, 1989, several countries had space technologies, satellite technologies. And then after that, the government and the industry worked together to launch kind of a fundamental satellites like a weather forecast, a weather satellite broadcasting. Actually, commercial flight started a couple years ago, and then to the space. So can you see this? 50 to 60 years.
So you think this is just sort of the natural pace of the technology diffusing from government to big companies to little companies?
Yeah, it's kind of flow. And so even 50 years later, space industry will be regulated, of course. as we see in this aviation industry.
Right.
But more players, more customers, more commercial players. So you'll see this.
Well, listen, Nobu, before we wrap up, I want to ask you what I call my magic wand question. And that is, if I gave you a magic wand and I told you that you could change one thing about Japan, anything at all, the legal system, the education system, the way people think about taking risks, anything at all to make it better for startups in Japan, what would you change?
One thing I don't like, so I really like Japan. I love Mount Fuji and Kyoto. But what I don't like is a kind of a mindset to ask something to the government. So let me explain.
Yeah.
So I was working for a Ministry of Finance in Japan, and I was doing the national budgeting from 1997 to 1999. At that time, Japan's economy was kind of downward in a lost decade. A bubble bursted in 1989, right? During that period, many banks went bankruptcy. All the people came to the Ministry of Finance to ask for money, budgeting.
Oh, I see. So you think that just people look to the government to solve their problems?
Right. Yeah, that's right. And then those kind of lobbying, not the right way, because there's a limit as a government. Government is not an almighty power.
Well, I think that's interesting because I think the government itself is trying to give that message very strongly to industry. So in the 50s and 60s, the government kind of was an almighty power in Japan. And I think, for example, when the Japanese government allowed Sharp to be sold, I think a lot of Japanese business were saying, no, the government will never let a Chinese company buy Sharp. They'll come in and they'll bail them out and they'll make it work. But they didn't.
Yeah, that's right. Maybe there's the tendency people we always see how governments think. But actually government does not have a good capability to solve everything. So looking at the space debris issue, everybody think, not only Japan, everybody thinks this as kind of a issue of the government or United Nations. But I don't think so. They cannot do this.
Well, I think it's going to require a lot of cooperation in the government. So before you use the example of the highway, clearing debris from the highway, but that only works because the government is there saying, you can't just abandon your car on the highway. We have to enforce these rules.
You're right. So we need rules, but we should not chase after the money. To remove the defunct car, broken car is not a one-day job. We have to continue this. So we have to do this as a business, not by the government funding. Space debris is the same. It takes a long time, or we have to do this forever. So it should be done by the business.
That's kind of the ideal situation, isn't it? Where the government sets the clear rules and then the market figures out the most effective solution within those rules. I think you're right. The Japanese people in general do tend to rely on the government more to solve the problems. How much of that do you think is kind of that unhealthy relationship of relying on the government to solve problems, and how much of that is sort of the positive side of that, which is more like wanting to work with your community, to work with others, not necessarily just the government?
Japanese people are loyal to the community where they belong. That might be in a village, that might be in a school, that might be in a company. I think that will generate a kind of solid, kind of a teamwork base. That works well.
Do you think that is changing? Do you think that Japanese business and society is relying less on the government?
Still relying on the government. But younger generation are more... Elder people are still remembering the kind of days when they had economic growth during 50s, 60s, 70s, 80s. But from 90s, Japanese economy changed. So the younger generation do not remember any those kind of good days, right? So I would say it's kind of Japan is a kind of pupa stage.
Okay.
So from looking outside, nothing's changing. But from looking inside, actually lots of things are changing in terms of the mindset, way of actually talking, way of communication or whatever. I mean, so I'm not sure this will become a butterfly or just end up with just a pupa.
But no, that does make sense. So you're saying that the generation of Japanese who came of age in the 90s, who were maybe born in the 80s, never saw this all-powerful government and therefore aren't relying on it as much and are being more independent and more likely to start startups.
Yeah. So as a Japanese, we have various type of the global companies. We are proud of that. I mean, Toyota, Sony, or whatever. But to provide more confidence to the younger generation, I think we should have more successful cases in new companies. SoftBank is doing great. That's a really amazing company. But it's already more than 30 years right now. If we have a much younger companies who are changing the business and society in the world, younger generation will be more stimulated, get more confidence. I believe Astroscale will be the one of them.
I think you're well on your way. And one of the most encouraging signs I see is almost every startup founder I speak with in Japan has plans to go global. So I think we are seeing that change.
Thank you very much. We are still on the way. More work to do.
Okay. Well, listen, Nobu, thank you so much for sitting down with me. I really appreciate it.
Thank you, team. Thank you for your time. Thank you.
And we're back. Okay. Space is cool, and I love nerding out over space tech. I mean, who doesn't, right? But this mission and this technology was not what I found most interesting about our conversation. What I found amazing and inspiring, really, was Nobu's approach to getting started with a huge problem. He started reading everything he could to understand as much as he could. And then he started attending conferences and then calling people up and scheduling meetings to ask for help. Now, I want to make something clear, because a lot of the business books and the self-help books that target the millennial generation give similar sounding advice, but they get it all wrong. Simply trying to connect to people you want to meet in order to get funding or to get a job is nothing special. It's common. It's even a little annoying. You're asking for people's time and not offering anything in return. What Nobu did was harder and riskier. He didn't have a fully formed solution. He had no immediate goals or ask in mind. But the researchers he met saw something that convinced them that he was worth their time. And what they saw was someone who had made a massive commitment to solving a problem that they had also thought was important, that they dedicated their research careers to solving. Nobu was offering them something that they considered valuable. And when you approach people like this, they're often more than willing to help. In fact, our conversation inspired me to get off my ass and move forward on a couple of projects that I've been putting off because I considered them just too complicated, or in one case, just too crazy. Hopefully, I'll be telling you more about those in the near future. But despite the Western stereotypes, Nobu and founders like him are not uncommon in Japan. In fact, they never were. It's just that before, the system made it very hard for them to follow their ambitions and to create new and innovative companies. But now that the system has started to change, more and more Japanese innovators are stepping into the spotlight, and you'll be meeting them right here on Disrupting Japan. If you want to talk more about space or satellites, and I know you do, Nobu and I would love to hear from you. So come by disruptingjapan.com/show129 and let's talk about it. And hey, I know you've been meaning to do this for a while now, but when you get the chance, please leave us an honest review on iTunes. It's really the best way you can support the show and help get the word out. But most of all, thanks for listening. And thank you for letting people interested in Japanese startups know about the show. I'm Tim Romero, and thanks for listening to Disrupting Japan.